Good afternoon, everybody. It's Charlie again. Firstly, a big thank you very much for all of those who provided input into the last video in terms of sort of nutting out some ideas for the next build and the one beyond that. That's been very, very useful, and what I am going to do for this particular build is look at both an SDR and a phasing rig. So what I mean by that is, so just looking at the this book here is experimental methods for RF design, has quite a good chapter on phasing receivers and transmitters, and what I thought I would do is build essentially one of these. So what I want to look at is building a direct conversion receiver combined with some digital signal processing to effectively build a software defined radio using the phasing technique. So what I'm thinking about doing is using some NE612s. So if I just move that book out of the way, this is what I'm thinking about doing. We're going to have the antenna coming in on the receive side of the house. We'll potentially look at some amplification. I'll start off with 80 meters, so this may or may not be required, but we may look at 40 and 20, and we'll see what happens there. For the mixers here, so this is going to be direct conversion, so we're going to, the local oscillator frequency, which we'll talk about here, will be at the incoming RF to produce audio directly out from a direct conversion receiver, and then we'll punch that into the Teensy, add some more phase shift, add things together, which is our phasing technique, to get our output, and essentially the reverse on transmit. So I won't go into too much details here, but suffice to say it's going to be an SDR using a Teensy, and using the phasing technique. So there were some comments about, and I totally agree with looking or not looking to use the SBL1 or the ADE1 mixers. They are not that easy to get hold of, not impossible, but and a little bit pricey. So what I want to do is use these, the NE612, well this is actually an SA612, a double balanced mixer. So we're going to use two of those. If I just have that sitting over here, and these will be these two mixers here. It'll be the same mixers used on transmit. These little mixers here have two inputs and two outputs, which will allow us to hopefully do a bit of sharing to use that for both the receive and the transmit side. These are quite cheap and readily available, so I thought that'd be quite a nice option to try and use this for this particular build for something different. The added advantage too is that these devices have gain. So traditionally in a software defined radio, certainly the simpler ones you'll see quite often after the passive mixer, there is some op amps are used to amplify the audio signal before being fed into either a computer sound card or some other device to finish off the DSP. These have amplification built into the conversion or into the mixing function, so it'll be interesting to see if we're going to get enough gain out of these to then feed straight into the Teensy. So in terms of the clock, which is these here, we need to provide this circuit with a Quadrature clock signal. So once again I'm going to stick with using as the main oscillator the SI5351. It is pretty cheap, it is pretty easy to use, so that's what I'm going to use for now. We could look at using a standard VFO, but like I say, for now I'm going to use one of these. In conjunction with that will be the SN74HC74. This is a dual D-type flip-flop. Now we need that, so the two flip-flops, and I won't get into this particular video, but we'll see it in the next one. We need those two D flip-flops acting as a team to divide the clock coming out of here down into two outputs. So we'll use this to clock this. The D-type flip-flops will be sort of slaved together, and we'll output two signals at our desired frequency, but they'll be 90 degrees out of phase. So it'll give us our quadrature. It does mean that that's a divide by 4 circuit. So this SI5351 here will be outputting our desired receive frequency times 4, which is really easy to do in the code. We just added times 4 in the very last line of the software. So if you go back to that video, a couple of videos back, looking at the software to drive this, in that very last line we just do a times 4. So it's actually really easy. Now there is a way, and I unfortunately have tried and haven't been that successful in actually producing out of the SI5351, out of clock 0 and clock 1, quadrature outputs down at least 3.1 megs. So I want to have 3.5 megs for the 80 meter band. It can be done, but I haven't worked it out, unfortunately. I did get some outputs. I did manage to get at that frequency quadrature outputs, but it was more fluke, and it wasn't logical enough for me to actually go forward with it. I couldn't quite make it work. So at this stage of the game, for now, I'm going to use, like I say, the dual D-type flip-flop arrangement to produce our quadrature clocks, and not here. If someone knows how to do this and is prepared to show me, hey, that's fantastic, I'd love to know. It just means we get to reduce this by one particular component. And as you've seen for many of my builds, I sort of err on simplicity, right or wrong, so I'm quite keen to sort of cut circuits down to make them as simple as possible. But anyway, that would be nice to be able to produce those directly in terms of quadrature outputs directly from this DDS chip. So like I say, that'll be our clock. That'll feed in to our NE612, and then we'll feed that into the Teensy. I'm going to use a Teensy 3.5. You can find it online, relatively inexpensive, and this is the audio board that goes with it. So that just marries up, and the audio board allows us through this header down here to feed audio into the Teensy and then to get audio out. And you can't quite see it, or you can just see it there. Those two inputs there is actually the microphone. So we'll use, as we were going to do for the last build, we'll use this microphone here, and we'll have that being fed into the Teensy audio board and into the Teensy. And then from that point onwards, we'll do all the for the transmit side of the house, the low pass filtering for the microphone. We'll do that all in software using digital filters, and we'll certainly do a series of videos looking at those. And then the output will be out of here on receive, and then we'll probably feed that into a probably an LM386 amplifier before going through to the speaker. So that's what we'll look to do. On the transmit side, as I alluded to in that last video, I do want to sort of reverse engineer this board here. We've got the big heatsink there, which is nice, and just sort of look at how this was put together, and see if there's any sort of lessons learned that we can use, and then look to reuse the 4 transistors there, which will be matched, which will be nice, and potentially use the balins just once we sort of work out exactly what's going on in terms of turns ratios and what impedances are trying to be presented to the bases of those devices there. So quite keen to pull that apart, and we'll get a good at least 20 watts plus, which would be nice. In terms of bandpass filtering on the receive, not drawn there, but coming in off the antenna, we'll have a bandpass filter. Once again, the 80 meter band is a wide band. It's 3.5 here in New Zealand to 3.9, and to have a pre-tuned bandpass filter to cover all of that and have it nice and peaky is difficult. So I'm going to once again use this thing here, which I quite like using. I have no problems peaking the receiver and therefore the transmitter for the operating frequency. So I have no problems with that, so we look to use that again. And as I suggested, or what I want to try and do in that last video, is have on this side, let's say the receive filter, and then have on this side the transmit filter. So one action will do both sides of the house, and then we won't get into any kind of relays switching this bandpass filter between the receive and the transmit side, which will be just through here. So on the transmit side we'll have a filter sitting in here before we amplify it, and on the receive we'll have it sitting there. So that's what I want to try and do, and if that works, that's great. If it doesn't, well then that was a good lesson learned. So in terms of the software, the drive, the 50, so again the SI 1551 and the DSP, that'll all reside on the Teensy. So this will do two jobs: A, to drive that, do all the DSP, and then for a display, I'm going to opt to use this one this time. It's just a 16 by 2 LCD, and as you can see there, it's got the I2C shield on the back. So we've got our SDA, our SCL, VCC and ground, which is the sort of the standard 4 pins for that. So we'll look to use that. It's not the best display in the world, it's slightly hard to read, but you know they are pretty cheap, so that's what I'm going to use for this particular build. So I think that's probably enough now for this particular video. That's sort of just outlining what I want to do for this one. We'll do again a series of videos. We'll do one looking at the 5351 and the dual D type flip-flop arrangement there, and we'll get that going. And at this stage of the game, I'm not going to filter the output of the 5351 before it goes into here. I'll just keep it as a square wave driving this, and then we'll see later on down track when we build the radio if that's going to cause us any grief or not. And we may have to look at doing some filtering there, we'll see. And then we'll do a video looking at the mixers, and then what I will do is we'll divide this project into two halves. We'll do a hardware half and a software half. So the hardware half will be everything leading up to feeding the audio into the Teensy, and once we have audio coming out of the 612s, we'll feed that into the laptop, and we'll use either or both SDR Sharp or HD SDR to just double check that our front end, so to speak, is working well. And then once we're happy that the front end is working, we can then go ahead and start doing the coding for the DSP, or that sort of that phasing technique to do our sideband elimination, or our unwanted sideband elimination, and we'll go from there. So that's what I'm thinking. We'll do the receiver first, and then we'll turn the attention to turning that receiver into a transceiver. Like I say, feeding microphone in, and then getting out our Quadrature audio, feeding it back into the mixers in reverse, and then we'll combine the outputs, amplify it and poke it out. So that's the sort of the high level thinking about how we'll attack this. Any comments, please sing out, and that's our way ahead. And then once we finish this particular build, then we'll perhaps turn our attention to maybe an analog phasing radio, which is something I haven't done before, which would be interesting. So any questions, please sing out. Any comments, again, please, more than welcome, throw them in. And we will see you very shortly with a video looking at, like I say, driving this with this to produce that Quadrature clock that's required to feed into our two mixers. Anyway, 73s, thanks all, and we'll see you shortly.